Hi guys, how are we all doing? I'm going to do the two solutions now to the questions that I gave you that we started the last day. I'm going to give you a good insight on how to go about doing this. Right, so the first question here was question 7 I'm going to do first of all. Okay, so if we start off and take question 7. Now, just 1 second. So this is, believe it or not, mainly algebra. It is a calculus question, but there's not that much calculus in it, and it really kind of focuses on the algebra. So what you're given here is the function f of x is equal to x to the power of p plus 2 times x to the power of p minus 1. It says find the derivative of fx. Okay, so we don't worry about anything else, and let's find the derivative first of all. So the derivative we know is we multiply by the power and reduce the power by 1. So the derivative, so p times x, so it's the power is p, and reduce the power 1, p to the power minus 1. Okay, and then it's going to be plus p minus 1 times 2x to the power of p minus 2. Now, what happens now is, this comes down to algebra, so I'm going to work this through, because if you look at the second part, it says show that f1 is equal to the derivative with x equal to 1 plus 5 minus 3p. So I'm going to get the derivative and sub 1 in for x. Now, before I do any of that, okay, what I'm going to do is I'm going to rewrite this in simple terms, okay, just to show you. So that's x to the power of p. So that's p, and that's multiplied by x to the power of p all over x. And the reason that's all over x is as follows, because that's x to the power of 1. Our rules of indices say that if you have the same base, you subtract the powers. So that's 1, so it will be p minus 1. So it's doing it the opposite way around. And this here is going to be, that's 2p minus 2, multiplying that out, times x to the power of p all over x squared. And again, because that will be p minus 2. So this here, p minus 2, is that p, take away that 2, because the x's are the same. That's what that means. That's what I'm doing there. Okay? Now, so now let's look at it. So now I want to get f dash 1. So I'm going to put 1 in instead of x. So if I put 1 in instead of x, that's going to be equal to p times 1 to the power of p over 1 plus 2p minus 2 over 1 to the power of p all over 1. Now, anything to the power of p, because p is a natural number. So 1 to the power of a natural number is going to be equal to 1. So therefore what I get is p plus 2p minus 2, which is equal to 3p minus 2. Now, if I add 5 and minus to take away 3p, so now what I'm going to do is 3p plus 5 minus 3p is equal to 5. So I know that this here is equal to 5. f1, if I put 1 in for x, right? So let's put 1 in for x. 1 to the power of p is 1, plus 2 is 1 to the power of p minus 1. P is a natural number, so because it's a natural number, that has to be the power of, that's going to be 1. So 1 to the power of 1, so you've got 1 plus 2, which is equal to, no, sorry, I did, that's, look at the bottom part here. Let's just finish this off here. Now that's p plus 2p minus 2, which is 3p minus 2. And then what I have here is it's 3p minus 2 plus 5 minus 3p. I jumped ahead of myself there. Minus 2 plus 5 is 3. 3p minus 3p is 0. So if I put 1 in here, that's going to be 1 to the power of p, which is 1. 2 times 1 to the power of p minus 1, which is 2. 1 plus 2 is equal to 3. So that means that they're equal. Okay, so just to show you here, look, f1 is equal to 1 to the power of p plus 2 times 1 to the power of p minus 1. So that's 1 plus 2, which is equal to 3. So this question here was really all about understanding indices and how they work. So, and just again, this is the key part, and this is the part that people find difficult. So when you've got x to the power of p minus 1, that can be written as, because that's p multiplied by it, that stays in its own out here. So it's x to the power of p minus 1. So the rules of interstate say, if I've got x to the power of n all over x to the power of n, it's equal to x to the power of n minus n. So that's just going to be p over 1. So it's just writing the other way. And that's why I can write it like that. And as a result, the reason I did that was because when I put 1 in there, anything over 1 stays as it is. So 1 to the power of p. So it just means I can evaluate it. And that's how we do that there. Okay, so that was question 7. Now, the next one then we had was question 8. So I'm going to look at that one now. And we had this one here. And this is similar. It's a similar style question, okay? So if you got stuck in question 7, try it doing now and then do 8 without looking at this answer. You can pause this video and then come back to it, okay? And see how you go, because all this does is it boosts confidence then. And even if you didn't get it, don't worry, that's no big deal. Okay, you have a look at it, try it with the guided help, and then leave it a day or two, then come back to it and practice it. Even though you've seen the answers, doesn't matter. That's how you're learning. That's what it's getting into your head, okay? So, I have fx is equal to ax to the power q plus a times 1 minus q times x squared. Find the derivative. So the derivative is q times a to the power of a times x q minus 1. We're going to do the same thing, look. And then this one here is going to be 2 to an a 1 minus q times x. Okay? So that can be written as q times a x to the power of q all over x plus 2a times 1 minus q x. Now, it says show that f1 is equal to f dash 1. So f dash 1, so I'm going to put 1 in instead of x. So that will get me qa. Now, it says here q is a natural number, so that's just going to be 1. So that's qa plus 2a times 1 minus q. So that's equal to qa plus 2a minus 2qa. That gets me 2a minus qa. Because look here, qa and qa are the same. So that's like one, you've got two similar things. So 2b minus 3b, or b minus 2b minus b minus qa. If you want, then you can factorize that a bit more. So you can say that a is 2 minus q. Okay. Now, let's put 1 in and get f1. So f1 is just going to be equal to 1 to the power of q is 1, so that's a plus a times 1 minus q times 1 squared. So that's going to be a plus a minus qa, which is 2a minus qa. It's the same as that. And again, the simple step to this one here is just dividing by the x, or knowing that that's what that is, and then filling them in. So again, just watch the steps, ignore this bit here, you start off and differentiate. So we start off and we multiply by the power. Q times a, so q here times a, qa, x, q minus 1, because you subtract 1 from the power. That gets me q minus 1. The 2 multiplied by the a gets me 2a. Times 1 minus q, x. 2 minus 1 is 1. Rewrite that, that's our rules of indices. Put x there. Now, let 1 x equal to 1. 1 to the power of q is 1, divided by 1 is 1, that's qa. 2a, 1 minus q, times 1, it's the same thing. Multiply this out. qa plus 2a minus 2qa is 2a minus qa. Take a out and it's 2 minus q. You don't even have to do that bit. And then look, f1, so 1 to the power of q is 1, so that means that's a. And a times 1 minus q times 1 squared. Multiply that out, that's your answer there. Okay guys, so that's question 7 and 8. So I hope you found some benefit in that. And again, that's a really good way of that's the type of stuff now you're going into the mentality or the mindset you need for doing honours maths. It's realising this is a calculus question, but you have to apply what you know with indices and algebra to do the question. Okay, any hassle with it, send me an email, just let me know. Okay, thanks guys.